How drones detect structural cracks using thermal imaging. This video explains how drones use thermal imaging to detect cracks, defects and hidden weaknesses in bridges, buildings and offshore infrastructure. No manual scaffolding, no shutdown windows, and no rope access. Just safe, precise remote inspection. Thermal imaging detects temperature differences along surfaces. Cracks, voids and moisture retention create thermal anomalies. These temperature variations appear as color gradients, usually bright yellows and reds for heat loss and deep purples or blues for colder absorption zones. When a structure heats and cools, damaged sections respond differently than intact concrete or steel. Even microscopic fissures store heat longer, causing warm streaks or cold lines after sunset. This is why most drone thermography flights are scheduled during transition periods, especially dawn and dusk. Thermal drones don't just show cracks, they show what is happening beneath the surface. Moisture ingress behind a concrete panel, corrosion under a steel joint, or delamination in paint layers all change thermal signatures. The drone flies in grid mode at consistent altitude and camera angle. Automated flight planning ensures uniform image overlap for post-inspection reporting. Smooth cinematic map grid animation. After the flight, the data moves into software. Thermographic images are stitched into a full structure thermal map. Analysts use temperature thresholds to identify defects. The software highlights anomalies and exports them directly into engineering reports. Structural engineers don't need to climb towers or hang off bridge trusses anymore. Drones provide millimeter-level visualization from safe distances, including offshore platforms where turbulence, weather and access make traditional inspection costly or dangerous. Thermal drones also help identify future failure points before they become catastrophic. Subtle heat signatures indicate internal stress long before cracks widen or materials shear. This is predictive maintenance rather than reactive. Many industries now rely on drone thermal inspections: bridges, port cranes, wind turbines, rail tunnels, shipping docks, and multi-story facades. Even solar farms use thermal for cell hotspots and row-level wiring faults. Accuracy matters. Thermal drones with radiometric sensors provide pixel-level temperature data, not just visuals. This means every pixel contains an actual temperature reading. Inspectors can confirm whether a crack zone reflects heat loss, moisture saturation or internal delamination. To summarize, thermal imaging drones detect cracks not by seeing them directly but by reading the way structures store and release heat. This reveals hidden fatigue that is invisible to standard photography and often invisible even during manual inspection. Remote crack detection strengthens safety, reduces inspection risk and keeps critical infrastructure in operation. Faster, safer, more accurate assessment without shutting down assets. Thanks for watching. Subscribe for drone explainer videos, cybersecurity break